Good evening, everyone. Welcome to the third batch of Plasma Workshop, and I'm Swarniv Chandra. So let's come to our mode of teaching. Okay. So you see, we have successfully four batches before you, and in this third batch we have the UG class and the PG class. Now let's get in because initially both the classes will have equal number of almost equal number of students and the same study materials. So let's open it. So from your viewpoint, let's get there and first come to the introduction to plasma physics. So here we have given two chapters or one chapter of the MIT course for your reference, and we have introduced also two lectures by Professor V.K. Tripathi. And someone was asking that in Chain's book, chapter 1, there is this Saha equation. So I have given some derivations also. So you just uh, have an idea on this lesson 1, okay? And then let's move to our next lesson, that is waves in plasma. For this, you can also refer to chapters 4 and 5 in Chain's book, okay. And here we have also given some lectures, but if you are not getting time or you are thinking that this is not related to your field of study, you may skip it, but these are good lectures, and these are also lectures from MIT OpenCourseWare. So I just gave the Hutchinson's material for your reference. You just open it, and by the time you just finish those first chapter in Chain's book, you will be able to answer this quiz. And this is very simple, some definitions that you are doing it, and what are Larmor radius. You may answer it later as well by the end of second week. And here we have got these materials, okay. And next, when we get to basic plasma astrophysics, we have just put up some lectures, YouTube lectures. So YouTube lectures which will be convenient for you to have an idea how the atmosphere looks, but you can also check some atmospheric plasma videos in YouTube that will give you an idea, because the solar corona, suppose here we get into YouTube and you can just say solar flares is, you can, if you're comfortable in Hindi, you can just try it, and this will give you an idea what kind of plasmas are here and what are the streamings possible and the uh, different instabilities. So you can have an idea. Those who are interested in astrophysical plasma, they can have an idea, nothing more. Now come to the class. Here this I have put up a PDF version of a book, Concise Introduction to Astrophysics by Khashali Reeve. Now this Khashali Reeve's book will give you an idea about astrophysics, but not much on astroplasma physics. So that we'll understand in the later classes. So, well, these are some of our papers we have put up for your reference. You won't need it initially, but later you can just get some of the models equation in the writing of an article. We have put it here. Now there will be some presentations. Whatever be the presentations we introduce here in the class, that's containing the normalization. You see what happens in normalization. This well, let me get here. Suppose in one of my papers only, if, well, in one of my papers, you see, we have governing equations. You see, whenever you are modeling something, you have your differential equations, equation of motion, equation of fluid, continuity, all these things. So these have some dimensionalities. You see, dimensionalities. It has got mass, charge, some constants, Planck's constant, 4 pi, electronic charge. So when you deal with so many constants, your become equations become very bulky, and it's problematic for you to deal with it. Okay, write it, or in every step you. So you just normalize it with some constants. What are those constants? Basically, these constants are of the same dimension. For instance, uh, if you take omega e or omega c, whatever, for the cold electrons, the plasma frequency, and it's the speed. You see, frequency by speed will have the dimension of length. So when the length x is divided by the something having the same dimension of length, so this term is normalized, so it is dimensionless. Similarly, time, if we get time multiplied with the frequency, this becomes dimensionless. So for your gravity, initially you can just put it bar over here for those terms normalized, or if you have already done it, no need. Just for the initial uh, people who are doing this normalization, for them they need to put bar or dash or prime, but as you are expert in this normalization thing, you won't need this kind of thing, you will be able to do it. And you see, we have normalized the velocities with their densities with their equilibrium densities. That is, suppose it is nj, j is a suffix, and is the electron density. So Ne is equal to Ne by Ne0. That is the equilibrium. So what is equilibrium and what is perturbation? Whenever there is a distribution of electrons in a plasma and you are creating some disturbances, so the equilibrium value will be will be disturbed. So there will be some perturbations or small fluctuations. So those fluctuations are what creating this wave mode. So we'll be studying those fluctuations in a greater details. So as you follow the lectures, you will feel it more interesting. I hope so. So these are some of the presentations which already you have in the uh, lecture classes. So it is also on the PowerPoints. So it is pen and paper. What did I do? I have put my videos here, some of the videos till 9, but so far we have made 17 videos, so that will be slowly updated. Okay, so how to deal with the fluid equation, what is linearization, what is how to use some MathCAD software to plot graphs in initial. So it's not that hard. MathCAD or MATLAB or Python, whatever you are comfortable with, you can do. We have no restrictions on your graph plotting software. So the dispersion relation, and this is something known as the uh, KdV equations, which study the we study is the solitary wave structure or the wave phenomena in plasma. Okay, so these are the lectures you will follow. So by this time you have learnt about normalization, simplification of equations, linearization, dispersion relation. You will have some assignments. Okay, and for batch 3 it is, I am giving you 1 week time. It's already possible for you because they batch 1 and 2 they had completed by today, and initially for batch 1 we extended the date. It is also possible for batch 3 we will extend the date by 2 or 3 more days. That's not an issue. And we have given all the assignments, and what are those assignments regarding the carrying derivation of the KdV equation, and there will be also some exercise on normalization. I think I missed it. Probably I will include. There are some assignments, and some of the assignments are required fast because you need to come up to a level, and those assignments or quizzes in your check your progress kind of thing you will be, and it will be helpful for your improvement. Well, we are not pushing you, just take your time to learn, enjoy your learning. So there is something Sagdi's pseudo potential method and something more. And if I go to the existing batch, suppose PG batch 1, okay, so how they have done, you see, they have carried out the same kind of thing. And don't worry about so many materials, I have uploaded it for your reference. Whatever you are feeling comfortable with, do it. So first you will be having that lesson 1, then try to attempt that quiz, then that few lectures, basic idea of the universe. If you are willing to learn about more about the universe and the plasma properties out there, this is a good lecture. But probably you will feel some, these are about I would say, let's say some well, these are about some 1 hour 37
First of
minutes.
all, can everybody read that?
Okay, this is a 37 minutes lecture. So if you are a fast this thing, you can just, I'm not sure, you can just in the app you can just check by putting the speed, you know. For instance, you take this video, you can get the speed, you can get this, change the speed. Well, I don't know, you can app, you can just increase your speed of, oh, playback speed, yes, you can just, it's normal, you can put 1.5, 2, it's up to you how much you can follow. Suppose we go to this video, we go to this video, he's teaching, just playback speed, let's not put it to normal, let's put it to 1.5, and let's see how it appears.
Acceleration, VDVDR is minus 1 over rho.
You need not to follow this
PDR
mathematics.
minus gravity.
You do not to follow
And I
this,
should have mentioned actually the notes that I sent around
mathematics.
are
If
2
you
PDFs, one of which is these slides,
just
the other of which is the kind of board work.
check it, okay, okay, fine. Now coming to this basic idea of universe I have given you. Well, so by that time you have understood something, we will be asking for check for yourself, and you just take your pen and paper, and as I've said, and I would also show you something in your class that you have some doubts, always put your doubts under this section, share your doubts, okay, share your doubts, because that is helpful for me to check. You see, they have asked a question, I have put, if you put your doubts everywhere in between any of the lectures, okay, between any of the lectures, suppose here you put your doubt, it would be very hard for me to just check those things, isn't it? So you will be given with this pen and paper expression and how to derive these KdV Burgers equations. My lecture videos are there, KdV assignments will be there, and I will try to put all the assignments under one head, quiz and assignments, so that will be very helpful for you. And regarding this plasma workshop, my lectures, well, that would be included. These are all these things. Now by the time you finish your initial part, initial week, you will be learning some of the mathematical tools, okay. So these are the equations. Forget it. Okay, so by the time you have learned this, and you see my lectures are here in the YouTube channel, and I'll give you the link, that is put plasma workshop workshop, plasma workshop, and you will find our lectures, all these lectures from video 1. So we have this next lecture, video 2, video 4, and all these things are out there. Once you get into, subscribe to my channel, that will be very helpful for you. Okay, so I would suggest whatever you have doubts, you put in this your class. Suppose go to the PG class batch 3, and where you pursue this, share your doubt. Well, some people have put their doubts already, you see. Shayan goes, sir, in Chain's book says that okay. Shayan goes, I have replied hopefully to your questions, and thanks a lot. Please help. Well, I'll help, definitely I'll help. Don't say like that. I'm always there to help. Sir, in Chain's book, how equation 2.0 counts? Can't understand. Well, loss cone. Well, loss cone is for the magnetic confinement. Well, I'll come to it. Okay. So thank you. And how to check these articles and all these things. Okay, I have just put the resources and feel comfortable. Thank you.